Hey guys, what's going on? We're back with day 23 here. Good job working with the implicit differentiation and second derivatives. Today we're doing an intro to PVA, which stands for position, velocity, acceleration. We're going to look at the derivative aspects of this. We'll come back to PVA once we learn how to do integration. But right now we're going to start solving problems, right? Applying our knowledge of derivatives to solve position, velocity, acceleration problems. Okay, so let's start with position. Okay. So if we're talking about a position time function, okay, this is a function that maps out the position of an object given the time. Okay, so all it's going to do is tell you where it is at a given time. Okay, it won't tell you how fast it's going, it won't tell you its acceleration, it just maps out position time. Okay, one thing to know about PVA is instead of using y and x, instead of x being the independent variable, t is going to be our time is going to be our variable here. Okay, and I'll catch myself accidentally using x there, but t is going to be treated like x is normally, and then our y could be anything. It could be y, it could be x, it could be v, it could be a, it could be s. So there are three different functions that we use for position time. So the three most commonly used functions that we use for position are x of t, y of t, and s of t. So if we see x of t, y of t, or s of t, that's usually a clue that it's going to be a position function, but we're going to want to read carefully to make sure of that. X of t is for an object moving along an x-axis. Y of t is for an object moving along a y-axis. And s of t could just be any general position. Okay. So, for example, if I told you an object moves along the x-axis, oh, actually, before we do that, let's talk about units. Sometimes they use units for position, velocity, acceleration. Sometimes they don't. If they don't use any units in a problem, then you do not obviously need any units in your answers. But if they do use units in the problem, we want to make sure that we use units in our answer. Now, in my class, my physics class, or Mr. Churchward's physics class, we probably most commonly used meters for units for position, and that'll be used sometimes in AP Calc as well. But AP Calc is notorious for using a wide range of units, so we have to be comfortable with whatever units they give. Again, since it's just a position, it's a location. It's given in terms of a distance from some kind of origin point. Okay, so but that distance could be meters or feet or yards or anything. So I'll just put some examples. The most common units that we see here are going to be meters and feet. Just be prepared that it could be anything. And again, that just gives its position in reference to some kind of origin point. So if you get a position of 3, that's going to mean 3 meters to the right of the origin or up from the origin. Okay, so we will get positive and negative numbers here for position. So let's look at an example here. Okay, so let's say a position of an object that's moving along the x-axis is given by x of t equals 2t squared minus 8t. Okay, so again, this is object moving along an x-axis. Okay, and for this specific example, I'm not going to use any units. Okay, so I just want to talk a little bit about what this means. So the question might be, what is the position of the object at t equals 1? So since t is equaling 1 here, I need to plug in 1 into my function x of t. So I'm going to do that by saying x of 1 equals 2 times 1 squared minus 8 times 1, which would be 2 minus 8, which equals negative 6. Okay. What this negative 6 means, right? So we think about how could a distance be negative 6, okay? But again, it's not a distance, it's a position. It's a position of negative 6. The negative, since we're moving along the x-axis, negative is always going to mean left. What this means is 6 units to the left of the origin. Okay, if I wanted the position at t equals, let's say, 3, right, then I would do x of 3 equals 2 times 3 squared minus 8 times 3. All right, 3 squared is 9. 9 times 2 is 18. Minus 24. And then get another negative 6 for 6 units to the left of the origin. Right? Now if I tried x of 4, right, x of 4 would give 4 squared is 16. 16 times 2 is 32. Be 32 minus 32. Right, but let's use 10 for an example. I'm trying to find one that's positive. X of 10 would be 200 minus 80. 200 minus 80 would be 120. That would mean 120 units to the right of the origin. Let me just write that out for you. Again, this positive 120 means 120 units right of the origin. So the sign here tells you, right? Now, if I gave you units here, it might be like 120 meters right of the origin, or 120 feet right of the origin. Okay, so that's our position function. The next type function that we have is velocity. Velocity function is almost always used going to be v of t, but sometimes in certain problems they'll have two different velocities going on, so they'll call one v of t and one they might name a different letter. Okay, but generally speaking, they use v of t for velocity. What's important to know about velocity is it gives you the rate of change of your position. Now, a lot of people use velocity and speed interchangeably, but in AP Calculus, there's a big difference between velocity and speed, okay? And it's that velocity has a speed and a direction. Okay, so we'll talk about that in a second. Units, since it's the rate of change of position over time, our units will be a position, right? So a distance divided by a time. And for units, we might see meters per second, we might see feet per second, we might see miles per hour, we might see meters per minute. Any kind of distance divided by any kind of time is going to be a velocity unit. It'll also be the same unit for speed. Okay, the difference is that velocity also tells you the direction that you're going. Okay, so that's very important. I want to add that in here. The sign of velocity tells you the direction that you are traveling. For example, if something is moving along an x-axis, plus will mean right, minus will mean left. Not whether you're right or left of the origin, that's position, but whether you're moving towards the right or moving towards the left. If we're moving along a y-axis, then plus would mean up, and minus would mean moving down. So depending on the context of the problem, whether it's an object moving along the x-axis or moving along the y-axis, okay, usually they're x-axis, but not always. A plus velocity is going to mean moving to the right. A minus velocity is moving to the left. If it's an up and down scenario, moving along the y-axis, then plus will mean up, minus will mean down. So here's an example. So let's say v of t equals 3t minus 8. And let's say we're moving along the x-axis. Okay, this time we're going to throw units in here. V of t is in feet per second. T is in seconds. Okay. So I want to know, what is the velocity at t equals 2? So we get a v of 2 equaling -2 here. Our units would be feet per second. And what this means is you are moving, because this is a minus here, we are moving left at a rate of 2 feet per second. Now, that doesn't mean you're left of the origin. You could be right of the origin and moving left, or you could be left of the origin and moving left. All it means is we're moving left at 2 feet per second. Okay. Let's try another one. The velocity at t equals 5. Velocity again, that would be v of 5 equals 3 times 5 minus 8. Okay. What this means is that t equals 5. See now that my velocity is positive? This right here means now we're moving right at a rate of 7 feet per second. Kind of hopefully getting the hang of that. Okay. So again, when our velocity is negative, that just indicates a different direction than a positive velocity. Okay. One more thing with velocity. On this AP exam, okay, they're going to ask you about speed from time to time. You need to your ears need to perk up, or your eyes need to perk up when you see the word speed, because we need to be careful. Speed, okay, is the absolute value of velocity. Therefore, speed is always positive. For example, the example I used, my speed at time t equals 1, or 2. So notice my velocity at 2 was -2 feet per second. That means I'm moving at a speed of 2 feet per second, because it's always the absolute value. Speed is always 100% positive. Okay, so my speed at time t equals 2 is positive 2 feet per second. My speed at t equals 5 is positive 7 feet per second. Okay, so whatever it is, whether it's positive or negative, it just becomes positive, and that's our speed. As a result, speed is always positive. The last function we're going to look at is acceleration. Again, they almost always use a of t for acceleration. Unless there are multiple accelerations, then they might give a different letter for a second one. A of t. Our units. Right? And a of t here is, well, acceleration is the rate of change of velocity. Therefore, our units are going to be a distance unit divided by a time unit squared. So it could be meters per second squared, feet per second squared, miles per hour squared, okay, etc. Okay. So that's our acceleration time. Okay, the last piece of information for this video is how we can use calculus to move between these three functions. Okay? Here's how we go. X of t is position, v of t is velocity, a of t is acceleration. Okay? To move down the ladder here, we just use derivative. So to get from a position function to a velocity function, I do the derivative with respect to t. To go from velocity to acceleration, I do another derivative with respect to t. So, for example, if I told you x of t equals 3t squared minus 5t, okay, what is v of t? Well, I would have to do the derivative of x of t. So v of t would equal the derivative of position, which would be 6t minus 5. So I just need to derive this position. Okay? So then I ask, what is a of t? Okay, from this same problem here, well, a of t is going to be the derivative of our velocity function, which is also the second derivative of our position equation, which would be the derivative of this, which would be 6. Okay? So to move down the ladder here, we do derivatives. That's it for today. I will see you guys in class on Monday. Look for one more video to come before Monday's class. Talk to you later. 2 chains, bye.